And now we're going to try and predict global warming and how its impact will vary over the next 100 years or something like that. And we're going to use a very simple model, but hopefully you'll be able to see how we could add more complications to it and make it better. Now, the simplest model, we're just going to say, okay, how many people are there on Earth? 7.5 billion at the moment, but that's going up. So we can add a little bit to it each year in our simulation, say make it increase by 0.5% to 1%, whatever, per year. Then we've got how much economic activity each person does. A subsistence farmer in a very poor part of the world has a lot less money and economic activity than some mega rich person in the developed world. So we're going to have a certain GDP per person, an amount of dollars per person, and that's also going to go up as the world gets richer. Now, of course, there are some countries like China where this is increasing very fast, and there are others like Australia where it's only increasing very slowly, but again, we're going to do a global average for the moment. Okay, so then we now have a prediction, not just for the number of people, but the total size of the world economy. But most forms of economic activity involve using power. For example, if you're richer, you might have bigger houses which need to be heated and lighted. You might drive more, fly more, consume more materials, all of which have to be produced with electricity. So what you've got to do is factor in how much power is used per dollar of GDP. You know it's going to go up. If your wealth becomes large, you're going to use more power. So there's going to be a certain amount of your megajoules per dollar. And that's going down as we become more fuel efficient. So, for example, a modern industry which produces smartphones, say a smartphone costs $1,000, but it uses less electricity than $1,000 worth of steel production or something like that. Also, our cars become more efficient, our planes become more efficient, our houses become better insulated. So we're going to have megajoules per dollar, and that's going to be going down with time as we get better at making things more efficient. And then finally, we've got to turn the total megajoules into an amount of carbon dioxide. And so when we factor all these things in, we can calculate the carbon dioxide for the whole world as it changes. And then factor in how it's going to affect the world's climate and get predictions for global warming. We'll do it numerically. I mean, you could write this all down as differential equations if you wanted to. The benefit of doing it numerically is actually, I think it's simpler, and also it means you can add more complications. Like you could say, let's imagine the economy crashes or something like that because of a virus or something like this. That's very easy to put into a numerical model, but much harder to put into a mathematical model. Now, of course, this model is too simple. A more complicated model would have to factor in different parts of the world, some parts with fast growth rates, some with slow growth rates. Presumably, if this model, if left to itself, predicts we'll all be toast at some point, but eventually as the climate gets really hot, maybe governments will finally start acting, or you might start getting people dying in vast numbers, the population starts going down, or agricultural productivity collapses. There are also feedback loops. For example, as it gets hotter, the ice on the North Pole melts, which means it absorbs more sunlight, and so on and so forth. But this is a first step as a simple model to predict what global warming could do. Now, as we do this modelling, we're going to get very nice graphs showing how the temperature of the world will rise. Now, the trouble with this is that the real data, you're going to see that rise due to global warming, but on top of that you're going to get all the random events, the weather that goes on from a day-to-day basis. For example, you get an El Nino, the temperature goes up, a La Nina that goes down, you get storms, and all sorts of hurricanes, and these things jump around a lot. So what in reality you'd get is your nice steady prediction, plus a whole bunch of noise due to various other things going on. And this, of course, is a major curse here. You can never say that a particular fire or drought is caused by global warming. All you can say is that the average is going up. But there's still going to be a lot of noise, and that makes it easy for politicians who don't want to believe in this stuff to say, oh, it's all just a noise. By the time the signal is much bigger than the noise, it may well be too late to do anything about it.